Monday lesson. So take a moment right now, answer the do now, and then we'll come back in a minute or two and talk about it. Okay, just for time wise, I'm going to pause it. You should pause it. I'm going to keep going with the video, so pause me now, and then try it, and then when you come back, you'll hear me talk about it. So, pause. All right. It says, sketch the images and answer. The triangle and rectangle shown have the same perimeter, which is the distance around. And we have to find the value of x. So if we put a number in for x, the distances around will be the same. How are we going to find that? And usually I invite a student up to come up and if they figured it out. But for me, I'll talk about it. They have the same perimeter. And same in algebra or math a lot of times means equal. So what I'm thinking is the perimeters, the distance around, are equal to each other. Right? Well, we have this distance is equal to this distance. And maybe we could use that to get the answer. Well, what's this distance if we simplify? If we add this plus this plus this? Well, what's x plus 4 plus 5x plus 1 plus 2x? Well, we want to know what x plus 4 plus 5x plus 1 plus 2x plus 5 equals. Well, this, if we simplify it, we add like terms, we get 1x plus 5x, that's 8x, plus 1 plus 4 plus 5 is 10. Okay, so the perimeter of this shape, the distance around, is 8x plus 10. Okay, how about the distance around this shape? And I tricked you a little bit. It's not 3x plus 9. Huh? Well, it's not 3x plus 9 because the distance around is 2x plus x plus 9 plus 2x plus x plus 9. So this isn't right because we forgot to include the 2x over here and the x plus 9 over here. So we actually have the perimeter of this shape to be 4x plus 18. Okay. Now that we know the perimeter of this is equal to the perimeter of this, so we can say that this equals this. Now what do? Oh, we just solve it like an equation. Yes, totally solve it like an equation. We'll take 4x away from both sides. And we gotta get x by itself, so take away 10. And we'll divide both sides by 4. And we found that x is 2. And that's what a student would have came up and shown you if you were in class. Okay. Any questions about the steps, finding the perimeters, making them equal? Great. Okay. So today we're going to jump to 1.8, which happens to do with rates, ratios, and proportions. And you should have studied it last year in 7th grade. We're going to connect it to equations, though, which is pretty fun. Okay. So either you wrote this down in your heading or you printed out the worksheets. Here we go. So I'll give you an example of a problem that you might have seen back when you were in 6th or 7th grade. In one town on the TV show The Walking Dead, hopefully people have seen that, the zombie to human ratio is 20 to 3. If there were 315 humans in a town, how many zombies would you expect to be in town? So, first I would ask people, well, what does it mean to have a ratio of 20 to 3? And students often raise their hand and says, 20 to 3 means there's 20 zombies for every 3 humans. Yes, so we expect to see 20 zombies for every 3 humans in this town. And we can use that ratio if we know that this town had 315 humans. How might we find out how many zombies there are? And I would invite student up and they would say, well, since it's 20 zombies for every 3 humans, and we know there's 315 humans, we got to think about how many zombies there are going to be. And a lot of people figure it out that, well, how many humans times what gets us 315? So our multiplier is 105, and we have to do the same to the top. So we get 2010 zombies, I think. Let me double check my math. Yes, okay. No, 2,100 zombies. That was silly. Okay, got it now. All right, and you may have set up ratios like this. This is 2 ratios that are equal to each other. And when you put an equal sign, they're a proportion, right? All right, let's take a moment, and this is the type of equation we're going to solve now. Well, we've been talking about solving equations, so what do we do to both sides? How are we going to solve this, right? I don't know. It looks terrible to me. You have fraction, and then a number of the fraction, and yeah, it looks terrible, right? I don't even know how to get started. Well, the cool thing is we're going to connect equations like this to what you've learned before about proportions. So stay with me. Okay, so go ahead and write down this equation. So if you want to find the value of x, you can find the multiplier, but you also learn something else, which is true about proportions. Does anyone remember a way you can solve proportions without finding the multiplier? Well, yeah. You might have known that cross products of proportions are equal. And we can use the fact that cross products of proportions are equal to solve it. And I'll give you an example. 1/5 is equal to 4/20. These are equal proportion. And if we cross products, 5 times 4 is 20, and 20 times 1 is 20. Declan, are you okay? We can see that when you multiply across, you get products that are equal. So we can solve this by using this idea of cross products. So we're going to take the 7 and multiply it by 3, and 2 times x. So 2 times x is 2x, equals to 7 times 3, which is 21. And when you cross product, you can see 2 times x goes on this side, and 7 times 3 is on this side. And we don't have a fraction anymore, which is great. And now, with one more step, we can solve this by dividing both sides by 2. And you get that x is 10.5. Sweet. So that's how you solve proportions in 7th grade. And this is our rule for cross product. So if we have our ratio, if we have A over B equals C over D, then we can create a rule. Well, what can we say, and what's true about A over B, which is equal to C over D? Using cross products, you're also allowed to say, and I usually take this from a student, that A times D is the same as B times C. So if we have A over B equals C over D, you can also rewrite it as A times D equals B times C. So that cross products helps us solve proportions, but the awesome thing is it also helps us solve more complex equations. Like here, take a moment, write it down. We have 2x minus 7 over 3x plus 9 equals 1/8. I have no idea. But this is a proportion. And we can use our rule about cross products. So you take 8, multiply it. So we get 8 times 2x minus 7 equals this times 1. So 3x plus 9, all of it, times 1. Okay. Now, I just wanted to show you the steps, but we can say that if this over this equals this over this, we can use cross products, and now we just distribute. 16x minus 56 equals 3x. We can distribute here. 1 times 3 is 3x. 1 times 9 is 9. Sweet. And now, an equation that was probably kind of hard to figure out, just by using cross products, we can get the answer. So now we just solve it like we normally solve an equation by doing things to both sides. Are you all right, Declan? And there we have it, right? A little work at the end, but that's work you've done before. So the new idea is just using cross products, right? Okay. So I have one for you and your partner to try right now. So let's use our new rule, use cross products. Yeah, I'm just talking on the video. Okay, go. I'll be out and done in a second, okay? That's Declan, my 5-year-old. He's always hungry. Okay. What are you going to do? Okay. Just for time-wise of the video, this is already recorded, but take a moment, pause it, but I'll get it started. Kind of tough equation. This 5 minus what over 2/3 x plus 5 equals 3/2. I couldn't guess what the answer is. Too tough. But once I notice that this is a ratio, two ratios, a proportion, I can use cross products. So 2 times all of this and all of this times 3. Now I have an equivalent expression using cross products that I can solve a little bit easier. 2 times 5, 2 times x, you get 10 minus 2x equals 3 times 2/3 x is 6/3 x. And then 3 times 515, obviously. Okay. And then 6 over 3, we can simplify just down to 2. There we go. Sweet. And now we can solve our equation, which I have no idea what that is. I still don't know because it's might be more challenging. So I'm going to solve this for x by doing things to both sides.